Imagine a world where time slows down and tidal waves reach towering heights. Miller's planet from Interstellar. But is it just science fiction? Or could such a planet really exist in our universe? In this video, we'll dive into the science behind extreme exoplanets, explore current discoveries, and see if we're any closer to finding a real-life Miller's planet. Stick around, because what we uncover might just blow your mind. And if you're as curious as we are, don't forget to like the video and subscribe to our Small World channel for more cosmic wonders. Miller's planet, that captivating world from Interstellar, is one of those cosmic phenomena that really gets you thinking. Imagine a place where time slows to a crawl, where an hour on the surface is equal to 7 years back on Earth. It's mind-boggling, right? This planet orbits dangerously close to a supermassive black hole called Gargantua, which is why time behaves so strangely there. But it's not just time that's warped. Miller's planet is also home to massive tidal waves, towering like skyscrapers, a result of the intense gravitational forces at play. But here's the kicker. Could a planet like this actually exist in the vast expanse of space, or is it purely a creation of Hollywood magic? Well, the concept isn't as far-fetched as it might seem. Science fiction often draws inspiration from real scientific principles, and Miller's planet is no exception. The idea of extreme exoplanets, worlds that defy our earthly expectations, isn't new to astronomers. In fact, we've already discovered planets that push the boundaries of what we thought possible. But finding a planet with Miller's exact characteristics, now that's the real challenge. It would need to be in just the right spot, close enough to a black hole to experience those wild effects, but not so close that it gets torn apart. As we dive deeper into exoplanet discovery, the question lingers. Could our technology uncover a world that mirrors Miller's planet, or is it destined to remain a figment of our cinematic imagination? Stay with us, because the next part of our journey takes us right into the heart of how we find these mysterious worlds. When it comes to the art of planet hunting, we're living in an era of incredible discovery. The universe, it turns out, is teeming with planets, many of them unlike anything we've ever imagined. So, how do we find these distant worlds, including the extreme exoplanets that could resemble Miller's planet? It's all thanks to cutting-edge techniques like the transit method. Imagine watching a distant star and noticing a tiny, almost imperceptible dimming of its light. This could be a planet passing in front, momentarily blocking a bit of the star's glow. This method has been a game-changer, helping us identify thousands of exoplanets. But there's more to the story. The radial velocity method, for instance, measures the subtle wobble of a star caused by the gravitational pull of an orbiting planet. It's a bit like detecting the tug-of-war between a planet and its star, even from light years away. But here's the million-dollar question. Could these methods help us spot a planet as extreme as Miller's? It's a tall order. Detecting a planet that orbits close to a black hole, like Gargantua, would be a unique challenge. Our current technology is more than capable of finding planets in various star systems, but a black hole's intense gravity might complicate things. However, advancements are always on the horizon. The tools we have today are just the beginning. As astronomers refine these techniques and develop new ones, the possibility of finding a Miller's-type planet becomes more tantalizing. And speaking of tantalizing, wait until you hear about the extreme exoplanets we've already found. Some of them make Miller's planet look almost tame in comparison. Now, let's talk about the cosmic oddballs we've already discovered. Planets so extreme that they make Earth look like a tranquil oasis. Take WASP-12b, for instance. This gas giant is so close to its star that its atmosphere is literally being stripped away, trailing behind it like a comet's tail. Or consider Kepler-13Ab, a world where temperatures soar high enough to melt iron, creating an environment straight out of a sci-fi nightmare. These extreme exoplanets push the limits of what we thought was possible in planet formation and survival. They remind us that the universe is a place of unimaginable diversity, where the rules of physics play out in ways that can seem almost alien to our earthbound understanding. But here's where things get even more interesting. Could any of these extreme worlds bear a resemblance to Miller's planet? We haven't found a planet with its exact characteristics yet, but the sheer variety of planets we've discovered suggests that almost anything is possible out there. While we've yet to stumble upon a planet with skyscraper-sized waves caused by gravitational forces, or one that experiences severe time dilation due to its proximity to a black hole, the examples we have found are a testament to the universe's capacity for surprise. These discoveries keep astronomers, and the rest of us, on the edge of our seats, wondering what else might be lurking in the cosmic dark. And speaking of surprises, there's one more puzzle piece we need to consider: the potential for finding planets like Miller's. Could our current technology be capable of such a discovery, or are we still missing a crucial tool in our cosmic toolbox? So, what are the odds of finding a planet that mirrors the characteristics of Miller's planet? While we haven't pinpointed an exact match yet, the idea isn't entirely out of reach. The universe is vast, and the extreme exoplanets we've already found suggest that nature might have a few more surprises up its sleeve. To find a planet that orbits perilously close to a black hole, like Miller's, we'd need a unique set of conditions. These would include a stable orbit in the habitable zone, a region where conditions could potentially support life. But that's just the beginning. The extreme tidal forces from a nearby black hole would need to be strong enough to create the towering waves seen in Interstellar, yet not so powerful that they tear the planet apart. It's a delicate balance, but one that's within the realm of theoretical possibility. However, theoretical possibility doesn't always translate to reality. The search for habitable planets has shown us that while the universe is full of surprises, it also adheres to strict physical laws. The likelihood of finding a planet experiencing such dramatic time dilation, for instance, remains purely speculative. Our current understanding of cosmic phenomena suggests that these types of planets might be exceedingly rare, if they exist at all. But that's the beauty of space exploration. Just when we think we've got it all figured out, the universe throws us a curveball. And speaking of exploration, let's not forget the role of technology in this quest. The tools and techniques we use are constantly evolving, bringing us closer to the day when we might just stumble upon a real-life Miller's planet. Up next, we'll dive into the technology driving these discoveries and what it might reveal in the not-so-distant future. As we venture further into the cosmos, the technology we use to detect extreme exoplanets becomes increasingly sophisticated. The James Webb Space Telescope, JWST, for example, is a game-changer in this arena. Equipped with advanced infrared capabilities, JWST can peer through cosmic dust clouds to observe exoplanets in greater detail than ever before. Its instruments might not only help us spot distant worlds, but also analyze their atmospheres for potential signs of extreme conditions, like those we see in Miller's planet. Imagine being able to detect the faintest signature of a planet's atmosphere or its proximity to a black hole. JWST is designed to make these discoveries possible. Yet, JWST is just one piece of the puzzle. The next generation of space telescopes, such as the upcoming Nancy Grace Roman Space Telescope, will further expand our ability to explore the universe. This telescope will use microlensing, a technique that observes how a planet's gravity bends light from a distant star, to reveal new and potentially extreme worlds. And let's not overlook ground-based observatories like the Extremely Large Telescope, ELT, which will provide unprecedented imaging capabilities and might uncover details about exoplanets that we can only dream of now. The combination of these advanced technologies holds the promise of bringing us closer to finding a planet with the extraordinary characteristics of Miller's planet. But as we push the boundaries of space exploration, we also open the door to new discoveries that could reshape our understanding of the cosmos. And speaking of future discoveries, let's look ahead to the missions that are set to push these frontiers even further. As we look to the future of space exploration, the upcoming missions promise to revolutionize our understanding of exoplanets, including those that might resemble Miller's planet. One of the most exciting prospects is the Nancy Grace Roman Space Telescope. Scheduled to launch in the near future, This telescope will employ microlensing to detect exoplanets by observing how their gravity bends light from distant stars. This method could reveal planets we've never seen before, including those in extreme environments. Imagine the possibilities. Planets orbiting close to black holes, or those with conditions so unique they might mimic Miller's planet. This mission could provide the crucial data we need to locate such extraordinary worlds. In addition to the Roman Space Telescope, ground-based observatories are also on the cutting edge of exoplanet discovery. The Extremely Large Telescope, ELT, for example, will offer unparalleled imaging capabilities, allowing astronomers to observe distant exoplanets with incredible detail. This technology could uncover planets with extreme characteristics and give us a clearer picture of their environments. As these missions unfold, they'll not only advance our search for Miller's-type planets, but also push the boundaries of what we know about the universe. The next few years could be a golden age of discovery, potentially revealing planets that challenge our very concept of what's possible. So, as we anticipate these future missions, one can only wonder what new wonders and mysteries they will uncover in the vast expanse of space. As we wrap up our exploration into the possibility of finding a planet like Miller's, it's clear that the search for extreme worlds is as thrilling as it is complex. While Miller's planet itself remains a science fiction marvel, the technologies and missions on the horizon give us hope that we might one day discover something equally extraordinary. From the groundbreaking capabilities of the James Webb Space Telescope to the upcoming Nancy Grace Roman Space Telescope and the Extremely Large Telescope, our quest to uncover planets with extreme environments is gaining momentum. These advancements not only enhance our understanding of cosmic phenomena, but also push the boundaries of what we thought possible in planetary science. As we continue our search, we can only imagine the wonders that await us. The universe is vast and full of surprises, and the quest to find a Miller's-type planet might just be the beginning of a new era in space exploration. Stay tuned as we continue to delve into the mysteries of the cosmos, always on the lookout for the next big discovery. The journey is far from over, and the potential for finding worlds beyond our wildest dreams is within our grasp. So, keep looking up and stay curious. The universe has so much more to reveal. The universe is a treasure trove of mysteries, and the search for extreme exoplanets is just beginning. With cutting-edge technology like the James Webb Space Telescope and future missions on the horizon, we're on the brink of uncovering worlds that challenge our understanding of the cosmos. Are you excited about the future of space exploration? What do you think we might discover next? Share your thoughts in the comments below. And don't forget to like this video if you enjoyed our deep dive into Miller's planet. Subscribe to our channel for more fascinating content, and turn on notifications so you never miss an update. If you're curious about planets more terrifying than hell itself, check out our previous video on NASA's most frightening discoveries. Stay curious, keep exploring, and we'll see you in the next adventure.